Assalamualaikum warahmatullahi wabarakatuh. I'm LYANA KARMILLA binti ANUAR KADIR 2020887256.
Assalamualaikum warahmatullahi wabarakatuh. I am NURUL Akmal Zakiah binti MOHAMAD 2020893414.
Assalamualaikum warahmatullahi wabarakatuh. I am NURUL HIJANAH binti HUSIN 2020482664. Today, we are going to present about applications of differentiations. So, what is differentiations? Differentiations is a process of finding a function that output the rate change of one variable with respect to another variable. It is also the actions of computing a derivative. The derivative of a function y less than function x of a variable x is a measure of the rate at which value y of the function changes with respect to the change of variable x. It's called the derivative of f with respect to the s. Derivatives are a fundamental tool of a calculus. So what is applications of differentiations? There are 5 applications of differentiations. The first one is related rate. Number 2 is graph of polynomial functions. Next is a graph of rational functions. Number 4 is apply maximum and minimum problem. And the last one is Rolle's theorem and mean value theorem. So we are going to focus on the maximum and minimum problem. What is maximum and minimum problem? Many applications problem in calculus involve functions. The process of finding the maximum and minimum value called optimizations. The restriction states or imply will determine the domain which we must work. The function together with its domain will suggest the good technique to use in determining a maximum and minimum value. For example, we use differentiations in apply to optimizing a company's income or minimize the cost. We also use it to find the least amount of material to produce a particular item. So when do we apply differentiations? We apply differentiations on the solving practical problems. We also apply differentiations to determine increasing and decreasing functions. Increasing function is if x1 greater than x2, then the functions x1 greater than functions x2. That means when x increase, the function x also increase. The decreasing function is a function which decreases as x increase. We also apply differentiations on find maximum, minimum, or point of inflections. The meaning of stationary point is a point on graph where gradient is 0. That means dy dx equal to 0. The 3 types of stationary points, which is maximum, minimum, and the last one is point of inflections. At maximum point, the gradient is positive just before the maximum. It is 0 at the maximum and it is negative just after the maximum. At minimum point, the gradient is negative, 0, then positive. Finally, at point of inflections, the gradient can be positive, 0, positive, or negative, 0, negative.
Now I'm going to talk about the other application of differentiation. So differentiation is used in mathematics or real life. For mathematics, we use differentiation to find the minimum and maximum values. Next, we use differentiation for rate of change of quantity with respect to other, increasing and decreasing function, tangent and normal to the curve, and lastly, approximate value of small change in a quantity. While in real life, we use differentiation to check the temperature variation, and we use differentiation to determine the speed or distance covered, such as kilometer per hour. And lastly, we use differentiation to calculate the profit and loss in business using graph. Now I'm going to give one example of application of differentiation. The question is, in a certain chemical manufacturing process, the daily weight Y of defective chemical output depends on the total weight X of all output according to the empirical formula, where Y is equal to 0.01X plus 0.05x squared, where x and y are in kilograms. If the profit is 50 ringgit per kilogram of non-defective chemical produced, and the loss is 40 ringgit per kilogram of defective chemical produced, how many kilograms of chemical should be produced daily to maximize the total daily profit? So, given y equal to 0.01x plus 0.05x squared, where y is the defective chemical output and x equal to all output, and the profit is 50 ringgit per kilogram of non-defective chemical, while the loss is 40 ringgit per kilogram of defective chemical. So, the question asks us to find the amount of chemical should be produced daily to maximize the total daily profit in kilogram. Note that we have to find the correct formula first for the non-defective chemical output, then we will find the chemical produced daily, which is X.
How the problem can be solved? Let me explain step by step. For the first step, we need to find a formula based on this equation. Profit x plus x minus y minus loss y. In this equation, we know 50 is profit and 40 is y. So we got 50x minus 90y. For the second step, we need to substitute value of y in the equation. Given y is 0.01x plus 0.05x squared. So we substitute the value of y in this equation and we got 50x minus 0.9x minus 45x squared. And the equation for p is negative 4.5x squared plus 49.1x. And the third step, we need to differentiate to find maximum daily profit. So before we differentiate, we need to state the equation of p. And we got the negative 4.5x squared plus 49.1x. And we differentiate the equation. And we got the negative 9x plus 49.1. And the last step for us to find the value of x when dy dx equal to 0. Negative 9x plus 49.1 equal to 0, and we got the value of x, which is 5.456 kilograms. The conclusion for this topic and also for this question, differentiate help us to determine the maximum or minimum value, identify the profit and the loss based on the equations, and the last one, use the correct formula to get the right answer. That's all from us. Thank you.